And this time I'll push the record button. So again, here is a picture of a typical gas furnace, and this isn't in the textbook. I have a bunch of things here that I didn't see in the textbook that we added to make this lecture a little more complete. Right, so we have so here's return air coming back from the space, going through a filter and a blower, right? So this blower is providing the force that moves the air around. We have a gas burner and a heat exchanger here, right? So this heat exchanger is taking the heat from the burning gas and using it to warm up the air that's provided back out to the house. So here's a diagram and a picture. This diagram is missing some components here. In this particular picture, there's also a air conditioning included with the furnace. That would be this coil section that's sitting on top of the furnace, right? How did I know that was air conditioning here? Well, A, this is what I do for a living, but B, I see these pair of copper lines connected here. So this would be the refrigerant lines coming from the condensing unit outside to the evaporator coil that's in the furnace. And I also see this little piece of PVC piping. This would be the condensate drain, right? So that when we're cooling the air, when we're air conditioning in Chicago, right, it's warm and humid in the summertime here. When we cool that air down, some of the moisture in that air condenses, right, and that condensate comes off of this coil here that's contained here, and it will flow down to drain. So again, that's a, and how did I know that's a gas-fired furnace, right? I see the black iron gas line coming in and connecting to the furnace as well, and also over here to the hot water heater. So as we saw from the poll, right, a common type of system in residential construction. So what are some of the things that we can have on a forced air furnace? We might have a humidifier, right? In the case of a humidifier, we're increasing the moisture or adding moisture to the air or humidity in the wintertime. We might do that here to make the room air less dry, more comfortable. And also actually safer, I think, with COVID, research was showing that, you know, our immune systems work better with more humid air. So this past winter, we had the humidifier in our house going like crazy because we were still scared of the COVID, and of course, you know, all the moisture was condensing on our windows. So that's a humidifier, a component that you might have on your furnace system. We measure the efficiency of residential heating equipment by the these little stickers that we have on here called the AFUE, Annual Fuel Utilization Efficiency, right? So this is a way that we rate the performance of residential and small commercial heating equipment, you know, just like we have miles per gallon. You know, the window sticker, if you happen to be shopping for a new car, you can see what the MPG rating is of your heating system. If you're going out and shopping for a new furnace, you can also look at the tag and find out how efficient that furnace is, right? So higher number is better, right? 100% would be perfectly efficient, but you see this range here of, 90 to 98%. Those are very efficient systems. So again, this is a picture of a high efficiency furnace. In this case, the vent lines are not sheet metal, but they're CPVC. So this is what's called a direct vent system, where it's going to bring in outside air and supply the combustion air to the furnace and take a lot of that heat out of the combustion, such that we can vent back out of CPVC or plastic piping, as opposed to a sheet metal vent. So in this case, this vent might go out the side wall of the house or the basement rather than going up the chimney. Here are unit cooling systems or window air conditioners. Again, if you don't have a furnace in your house, if you live in an older house like we do, we have a window air conditioner. I used to be able to hump that beast from the attic and install it in the window every year. I'm getting too old to do that, so I have to bribe one of my neighbors to help me carry the air conditioner down from the attic and stick it in the window. One of these days, we're gonna put a different system in our house so we don't have to do this anymore. Yes, Nicole.
When you refer to a different system, I know that a lot of people in the older homes use those unit systems that go in the wall. Just look like a little box that's sticking on the wall. Is that
Yes.
considered a unit cooling system also?
Yes. For an old, and I think I have pictures here. I think we have two different options for cooling a. In our case, I think I answered my poll with hot water radiators. So I have an older home with a hot water boiler and hot water radiators. So right now I cool with a window air conditioner, but I could either have a duct-free split system or the space pack, and I'll show you the space pack or high velocity system. The high velocity systems are the ones where it's got little flexible tubing that you can fish through the walls. I think I have a picture of that. So typically with our with the furnace we saw before, with the A coil or the evaporator coil in the furnace, we have a condensing unit that sits outside, right? This is the condensing unit. This is typically called a split system, right? Because we have the the components of the system, part of it at the furnace, part of it on the condensing unit sitting outside. Right, so the air conditioning system is actually a sort of a pump. It's moving heat it's taking air out of the airstream inside the house and rejecting that heat to the out of doors. So again, in the summertime, if you go and stick your hand over the fan here, that air that's blowing out of the condensing unit will be hot air, because the air conditioning system is moving heat from inside the house to outside the house. We're rejecting heat to the out of doors. So again, if you have a furnace and your house is air conditioned, you likely have something like this sitting outside. And here's those same copper lines, right? Pair of copper lines we saw before. That's where the refrigerant, either liquid or gas, liquid or vapor, moves between the condensing unit and the evaporator coil in the furnace. Right, so in our split system, we have a couple different components. We have this condensing unit sitting outside. we have this evaporator or A coil, right? They use the term A coil because that's kind of the shape that it has, right? So this would be called a cased A coil. So you have the evaporator coil, and then typically you have these copper tubes or a line set that connects the parts and pieces, and then this system is charged with a refrigerant. We used to use the term freon, right? But we have a refrigerant or working fluid in the system that we pump around to provide to move the heat from evaporator out to condenser. Right. The other component we typically have in our system is some means of control, a thermostat. Right. Could be simple or it could be, fancy like the stuff nowadays, this Nest thermostat where you can have it tied to your smartphone. Right. So you can, if you're so inclined, I mean, setback thermostats can have a schedule programmed in them. Nowadays, you can, if you're driving home and want to turn your air conditioner on and cool the house down before you arrive, you can pull out your smartphone and tell your Nest thermostat to turn on and cool the house down. Right? Things that didn't exist when I first got into this business many years ago. This is an example of a unit cooling system. This is called a duct-free split system. So in this case, we have this indoor unit or evaporator that can hang on the wall inside the house. And outside, we have this condensing unit. So this would be a way to, and these two things would be connected by a line set again. But this would be a way that if perhaps you wanted to add air conditioning to an older house that has radiators, we could do it in a room or rooms with a duct-free split system like this. I was actually just talking to my brother-in-law about it, right? I'm the mechanical engineer in the family, so all my family, or in this case, my wife's family, calls me for advice on heating and air conditioning, right? Just like in your family, you might have someone who's the lawyer who you call if you have legal troubles, or hopefully your family is blessed to have a plumber, right? Plumber is probably the important person, or the electrician perhaps, right? If you have an electrician in the family and you want to move an outlet, you call your brother-in-law the electrician. In my case, I'm the mechanical engineer, so my brother-in-law outside of Denver wanted to put in this duct-free system in their house where they already had hot water heat. So in this case, he found a system where he can connect up multiple evaporators up to a single condensing unit. So in this case, they're going to be able to install air conditioning in their house with a bunch of evaporators connected up to a common condensing unit. So I thought that was pretty cool. So that's a duct-free split system. Again, just like we had AFUE as a measure of efficiency of heating systems, we have SEER, seasonal energy efficiency rating. We have that as a way to rate the performance of air conditioning systems. Nowadays, the building codes might mandate efficiencies. But in this case, again, a higher SEER is better. So if I was going to go out and buy an air conditioner, I think that one of my wife's sisters was asking for air conditioner advice, and I said, "Oh, go buy an air conditioner that's at least 16 SEER, right? More efficient than pay a little more money, but you get better efficiency, and it's going to cost less for you to operate. We can also heat and air condition with a heat pump. So a heat pump system is going to look a lot like an air conditioning system, like that split system that we saw before. The only difference in a heat pump system is that the action is reversible. So in the summertime, a heat pump can take heat out of the house and move it to the out of doors, function just like an air conditioner. In the wintertime, that action can be reversed such that we take heat from the out of doors and we raise its temperature and deliver heat into the house. Yes, Christoph.
So a heat pump is only, are we only using it in regions that are maybe more cold most of the year to prevent the AC unit from getting too cold and maybe getting damaged until it gets warm again?
Actually, I see heat pumps kind of in the middle part of the country where it's not quite as cool in the wintertime. So I think air source heat pumps are less common in Chicago. Let's say if I was in Southern Illinois or Kentucky or Tennessee or someplace in the middle part of the United States, I would probably use an air source heat pump because the winter is not quite as severe, right? This heat pump has to work really hard if it's trying to take heat out of 0 or minus 10-degree air in Chicago and heat the house with it. As a matter of fact, it probably doesn't work that terribly well when it's that cold outside. But if you happen to live in, say, Nashville, and it's 35 degrees on a cold winter day, then a heat pump works just fine. So I think I said typical in warmer areas, less common in Chicago.
Oh, okay, so that was my fault.
No, no worries. No worries. Good question. Just like lots of things in architecture and design, right? The same, the same solution doesn't apply to every site. The same solution doesn't apply to every climate zone. You have to pick the thing that makes the most sense for your particular circumstances. Again, just like we rate these other pieces of residential equipment, we have an HSPF, or heating season performance factor, to rate the air source heat pump. So again, a heat pump is all electric. The split system that we saw before has gas heating and electric air conditioning. I'll talk about this a lot more in the 110 class, and hopefully if we have a lecture at the end of this class, we'll talk about kind of green construction practices. But certainly one of the things that we're trying to do is have more renewable sources of energy in the electric grid. So you'll probably see more of a trend to moving to electric heat pumps as opposed to natural gas heating. As heat pumps get better and more efficient, then they're better able to work in climates like Chicago. So you'll see more of that sort of thing in the future. In a hydronic system, right? You see that I've finally found another picture out of the textbook. This is figure 14-4 on page 244. In a hydronic heating system, we are pumping, we have piping, and we're pumping hot water from the boiler to various radiators or baseboards throughout the house. So this is what's called a hydronic or water-based heating system. With a hydronic or hot water system, we have a boiler. Boilers can also be steam boilers, right? In a lot of older Chicago homes, we'll have radiators, but they will be steam radiators instead of hot water. Sorry, I couldn't, when I was looking for clip art on the website, I couldn't quite get this name of the company out. But here's an example of boilers, right? These are both gas-fired boilers, right? Here's our gas line coming in here. Here's a pump that's moving the water around. Here's our sheet metal flue connection. So we're combusting or burning gas to heat water and circulating that water to the house. Here's another example here. This would be a higher efficiency system. How do I know it's higher efficiency? Because we have these same CPVC pipes connecting, bringing combustion air in from the outside and putting it back out or delivering it back out to the outer doors again. In this case, it looks like we have two different zones of heating, right? Because there's two sets of pipes, two circulating pumps. So in this case, perhaps maybe the house is split. Perhaps the first floor of the house that has the living areas are on one zone, and the bedrooms are on a separate zone, right? So you can control the temperature differently in different times of the day in different zones of the house. Right, again, here's some other examples of boiler systems. Right, in this case, this is a hot water boiler serving a radiant floor. Right, how do I know it's a radiant floor? Because it has this, this is the typical way that radiant floors are done. You have this piping manifold, and then you have lots of pipes that are set in the floor, and we're circulating lower temperature water around and keeping people comfortable by warming the floor a little bit. This is actually a comfortable and efficient way of heating a home. Right, so in a hydronic or water-based system, what are some of the different elements that we can have in the space? Right, we can have hot water baseboard. Right, we need some way from the heat from the hot water to heat the air that's in the room. So in this case, excuse me, we have hot water circulating through copper pipes and aluminum fins, and the air gets warmed as it passes over those aluminum fins, and we have some movement of warm air into the house, right? So this is called the baseboard, or sometimes it's called fin tube. Right, here's radiators, cast iron radiators. Right, this is what I have in what Francis and I have in our old house. You might have this in your house as well, right? Cast iron, big heavy piece of cast iron sitting on the floor that can be either hot water or steam. And folks have kind of updated the idea of a cast iron radiator with what are called panel radiators. Again, the same idea, kind of updated look and feel. I think radiators are comfortable because you have this large surface area that's radiating heat, making you feel warm. So I like radiator heating systems. Yes, Nicole.
So often you will hear people say that the radiators and the boilers tend to increase the moisture in the air, but I never really understood how that was true because the moisture is not escaping the radiators. So is that true?
It depends. In the case of a hot water system, the hot water system or hydronic system is closed, hopefully, unless it's leaking, which is bad, but under normal operation, it should be a closed system so that water is not leaving the system and it's not making the air in the space more humid. However, if you have a what's called a one-pipe steam system, right? If you have a steam radiator and has a little silver vent on the side of the radiator and it hisses when the heat comes up, in that case, there's a little bit of moisture being added to the space because some of that moist air is being expelled from the radiator. But again, I don't think it's not that big of a deal, right? If you happen to live in an older Chicago, let's say a courtyard building, a 6-flat or a 12-flat, in an older building, you could easily have a steam radiator. And again, if you grew up in that kind of a house or an apartment, then you got used to the radiators hissing when the heat came up. But again, I don't think that doesn't add that much moisture to the space. So.
Okay, thank you.
Oh, you're welcome. Good question. Here's an example of a radiant floor system. So again, in a radiant floor system, we have thin tubing, probably something like PEX. Remember, we saw PEX last time, PEX cross-linked polyethylene, right? That's a typical, right? Actually, it says it here, right? Here's PEX tubing, right? That's a typical, so we're going to bury thin plastic tubing in lightweight concrete and put flooring over it, and then we're gonna circulate warm water through that piping and heat the building that way. So that's a hot water radiant floor system. And again, if you remember that picture of the boiler that I had a little while ago, right? You have a manifold with lots of connections because you might have a different piping connection for different areas of the house. And in this case, in this particular detail, we have some insulation to make sure that that heat goes upward into the space and say not down into the basement. Right, here's some other kind of details for how you might incorporate a hot water radiant system into wood construction. So I said here, high degree of thermal comfort, right? Radiant systems, if they're done well, are very comfortable. Right, just like when you get out of bed in the morning on a cold winter's day, it's kind of a shock when your feet hit the cold floor, right? In this case, if your feet hit a nice warm floor, you feel comfortable. And from an efficiency or from a system design standpoint, radiant floor is a good match for some of these high efficiency condensing boilers because we can run the temperature of that hot water in the radiant floor system fairly low, right? We're making, say, 100-degree water, 110-degree water, right? That's a lot cooler than what we normally have in a hydronic heating system. We can also do the same thing with an electric radiant floor, right? Same concept as hot water radiant. We're using a different fuel source. We're using electricity, right? A good example here is if we want to add some supplemental heat in the bathroom or something. We could often do it this way, right? You want to add a little bit of extra oomph to the bathroom so you have a nice warm floor when you step out of the shower. This would be a good application. Okay, I think I was alluding to this before, Nicole. Yeah, this is a way that we can add air conditioning to a house that we might already have hot water radiators or steam radiators is what's called a high velocity air conditioning system. So in this case, instead of having the air being delivered by the larger vents that we're used to in a forced air system, they come out of these little round outlets, right? That's it's a little hard to tell here, but that outlet is probably 2 inches in diameter or something. So we're blowing air at a high velocity and using that to air condition the house. So in the case of air conditioning, that high velocity is not objectionable to us because we feel more comfortable in the summertime when we have a lot of air movement. And the system is all based on, flexible tubes that are, 2.5 or 3 inches in diameter, and they can be fished through the walls. So this is a good system if you want to retrofit air conditioning into an older house that already has hot water or steam. In our case, I think my wife has been clamoring for this in our house. I think we decided we're going to wait another year or two because with the COVID, there's still a lot of disruptions in the supply chain. So we're going to wait another year before we put in the high velocity system in our house. So eventually I won't have to hump that air conditioner down from the attic. Again, components of a high velocity system. It's going to look similar to the split system. There'll be a blower unit, quite often mounted up in the attic. And then it's a little hard to see here, sorry. Right, we have this blower unit. We have the same condensing unit outside, but the key is this. It says 2-inch or 3-inch insulated ductwork. So this is what the contractor can fish through the various walls of your house and retrofit it into an existing structure. That's really the key. And then we can move that air through these skinny little ducts because we're doing it at a higher velocity. And you have, again, these same round outlets that we saw in the previous picture. So my daughter just bought a house. She's got hot water baseboard, and the house they live in, the previous homeowners had put in this high velocity system. So they have hot water heat, hot water radiators, and high velocity air conditioning. An evaporative cooling in an evaporative cooling system, we talked about it before. We're moving air over a wetted media. The air is cooled as it passes over that pad. So we're adding humidity. We're adding cool, humid air into the space. But again, not something we can do in Chicagoland. It doesn't work here, right? The summertime air is too humid. Right, so if we're in Phoenix, yes, we could see a system like this, quite common. In Chicago, no. If you happen to drive around in Phoenix, you might see this square little box on lots of people's roofs that is an evaporative cooling system, sometimes called a swamp cooler, right? You're not going to see swamp coolers around here. But if you're in Phoenix or Tucson or someplace like that, they would be quite common. In commercial construction, especially smaller commercial construction, we will quite often have what's called a rooftop unit. So this is a single package that provides heating and air conditioning. There's a wide range of capacities and types. This sort of thing, a rooftop unit, is fairly rare in residential construction, but it's going to be very common in small commercial. Why is it very common? Because it's cheap, it's easy. We can provide these services. We put it up on the roof and we're not taking up valuable floor space. So a common solution to small commercial construction. Again, in commercial construction, we'll typically have, as part of our HVAC system, we'll have an exhaust fan. Right? We might have it in our houses, right? We probably have a range hood in our kitchen. We might have an exhaust fan in our bathroom. Certainly in commercial construction, we're going to have exhaust fans in things like lavatories and kitchens. Again, we want to remove air from some of those spaces where we don't want that air to be recirculated back to our furnace or rooftop unit. So in a air handling system with a furnace or a rooftop unit, how does that air get from the furnace out to the space? It gets out to the space with ductwork, right? Ductwork is typically made from galvanized sheet metal. Remember, galvanized, we said, is a zinc coating on metal to provide resistance to corrosion or rusting. Ductwork is typically field assembled from pre-made sections of ductwork. So, the sheet metal contractor will either look at the plans or decide, hey, I need a piece of ductwork. Right? This could be the 20 by 14. So they either buy sections of ductwork and assemble them on site, or they go to their shop and they fabricate those sections of ductwork and they bring them out, and then the tinners put it all together. Right, so that rectangular ductwork, again, if it's common sizes, it can come from a supply house, or in the case of a decent sized mechanical contractor, they may have their own shop where they fabricate that ductwork. Again, the ductwork is fabricated, it's tagged, and in this case, you see they've protected that ductwork so it doesn't get dirt or moisture in it. And they load all this on the truck and it gets trucked out to the job site. And again, the tinners are the sheet metal tradespeople put that stuff together. Again, we can do the same thing with round ductwork. So purchased in stock sizes, assembled in the field. Is the ductwork welded? No, it is not. Well, it's going to depend on the characteristics. It's a little hard to see in the picture, but generally speaking, these sections of ductwork are joined with what's called a cleat. And I don't really have a good picture. I'll have to find a picture of how ductwork is joined. But there'll be the two pieces of the two sections of ductwork will come together. Again, it's hard to see in the picture here, but there'll be let's just say these two sections of ductwork are placed next to each other, and there'll be let's call it a metal strap is not the right word. I'll find a picture, but there'll be a little metal connector that holds those two pieces of ductwork together. So it's typically not welded because the amount of pressure that that ductwork is taking is relatively low, that these strap or cleated connections will handle the pressure requirements. Does that answer your question, Ayana? And I'll see if I can find a better picture of that. So we would typically use a cleated connection in rectangular ductwork. We might use it in round ductwork as well, or we may have the sections of ductwork may press together. In the case of a spiral ductwork, again, this is fabricated in a machine, so the spiral ductwork would come in long sections, and again, those sections are joined together. And I'll have to get you a little more detail and explain how this stuff is put together. But again, these are all things that are shop fabricated and then brought out to the job site and assembled. Right, so in the shop, you might get, let's say, 10-foot sections of spiral, and the tradespeople in the field assemble those sections and they suspend them from the construction, right? They have some kind of hanger that's holding that ductwork system up. So the kind of last piece of the puzzle are the registers and diffusers, right? This is what distributes, supplies air to the space, returns air from the space, and hopefully if either the mechanical contractor, if that's the person who is doing the design, or the mechanical engineer, hopefully if they've done their job well, we're distributing air at a velocity that does not cause drafts or discomfort or noise, right? Those are all things that we don't want to have in our HVAC system. We don't want it to be noisy, and we want the distribution to be such that it's not drafty. Right, so this is what those of you who said you had furnaces in your house, you could easily have something like this sitting in your floor or on a sidewall someplace. If you're in a commercial building, you're likely to see something like this, right? We could have these ceiling diffusers that are designed to lay into a 2x2 or 2x4 ceiling system. So this would be a supply diffuser and a return grill. If we're sitting in the classroom at Triton, I would have you look up and we would see these things right above our heads, but we're not sitting in a classroom at Triton, so we have to look at a picture of these things. Sorry, I lied. There's one more component here, that is filtration. So one of the things that we want to do in an HVAC system is take some of the contaminants out of the air, right? Clean the dust and the dirt out of the air so we're not circulating that stuff around again. So we pass the air through some kind of media that collects those particles, that dirt. Those air filters, depending on their application, can either be washable or disposable. Nowadays, I think most filters are disposable or throwaway. Right, so in our furnace, we have something that might look like this, that slides into a little slot on the side of the furnace someplace. So hopefully those of you who answered furnace hopefully someone in your family goes and changes the filter occasionally. I put these slides together last summer, right, when we were all worried about the COVID, right? We actually are still worried about it. I think that what we found is that the primary means of transmission of COVID is not people touching dirty surfaces. It's the transmission of aerosols in indoor spaces, right? Aerosols means that when someone who's infected sneezes, they expel little droplets of air, of moisture, right? And if they don't happen to have a mask on, then those little droplets end up in the airstream and they get carried around to the other people that are in that space, right? That's what we found to be the principal means of transmission of COVID. So in my business, right, this is what I do for a living is, so I've obviously read stuff in my trade journals. And one of the things they talk about is how good is the air filter that you have in your system, right? MERV is the way that we rate air filtration, right? A higher number is better. So recommendations came back that if you want to try to filter some of those aerosols out of the airstream, then we should have MERV 13 filtration. Right? What are we trying to filter? Right? That little bugger over here, that coronavirus, is a very, very small particle. So smaller is harder to filter. Right? You see a human, by comparison, some larger particles. And then we have that little problematic coronavirus over here. So since smaller is harder to filter, where are we likely to find this sort of quality air filtration, right? A MERV 13 filter. Are we going to see it if we go to a hospital? Yes, because the HVAC systems in the hospital are designed to prevent this sort of transmission. Do we have that sort of thing in a school or university? I would say we probably do. I think Triton has worked very hard to bring their air conditioning systems up to snuff. If I'm going to a bar or restaurant, am I going to have MERV 13 filtration at a bar or restaurant? Probably not. So I'm still not going. I've been vaccinated, but I'm still not going out to a bar or restaurant because there's a lot of people crowded into small spaces, and there's lots of aerosol transmission of COVID, and the amount of air movement and the amount of filtration is not what it needs to be. Hopefully we'll be able to get past this stuff pretty soon, but we don't know. So again, in how do we make buildings more efficient? How do we make them greener? One of the ways that we do that is by making sure we have good control on our system. I think I showed a picture a few slides ago about the setback thermostats or the Nest thermostat, right? So we can have our thermostat turn the heat down when we leave, set it back in the wintertime, set it up in the summer. And then when we're driving back home, we can get in our smartphone and turn the heat back on or turn the air conditioning on. And I talked about AFUE and SEER. So any questions? And I actually was watching the time pretty well here. Any questions, folks, on HVAC? Other than I've got to have some follow-up to tell you how ductwork is joined together. Yes, Christoph.
This is it's a question loosely based on the chapter, more so since you're a mechanical engineer. Do you ever remember reading about the rain clouds that were forming in the Boeing factory for the planes?
I do not, to be honest. obviously rain clouds form based on combination of moisture and temperature, right? Just like fog.
That and
Right?
the ceiling height was so high it gave them room to form. I was just curious in your mind, right? What I guess what kind of lack of air filtration or air movement would have to take place for something like that to happen indoors?
I have to think about it. It's probably whoever designed that space didn't think about all the variety of conditions that could occur, right? Because that's going to be, I don't know if this was Boeing in Seattle or in South. I think Boeing has factories in Seattle and also in South Carolina.
This was Seattle.
Okay. Yeah, I mean, Seattle is fairly humid, so I could see if you have a lot of humid air that gets cooled down, that some of that humidity is going to come out of the airstream. So I could see how that could happen. And I'm sure somebody probably had to do something about it, right? Because they don't want their airplanes to get rained on when they're in the factory. You know, when they're out of doors, they get rained on all the time, but they probably don't want them rained on when they're being constructed. But yeah, that's a function, right? We have, air is a mixture of, has both the air and also moisture in it, and the amount of moisture that air holds or can hold is a function of temperature, right? So when you take just like the way our air conditioning systems in Chicago work, right? We have warm, humid air, and we pass it over that evaporator or the A coil, which has a cold surface. Then some of that moisture condenses out of the air, and then we feel more comfortable because we have cool, less humid air being distributed to our house. So it's all about the properties of moist air.
Gotcha.
Okay. Any other questions? Okay. Well, on Thursday we will. Why don't you take a look at the test your knowledge on page 247? We'll go through the answers with those on Thursday, and then we'll also look at HVAC in both residential in Marseille and in Delhi. And again, if you plan to come to Triton on Saturday for special help, just please send me an email. Let me know you're coming, so I don't want to drive out there for nothing. And also, if you have some things that you want me to help you with, give me a heads up so I am prepared.